Good morning to everyone. Welcome to MNG College. Myself Nayana. I am going to teach about physics class and let us study about in the unit. This is a unit 2, units and measurements. Then in this class we are going to discuss about dimensions. What is meant by the dimension? The definition of dimension is dimensions of physical quantities means expressing them in terms of fundamental quantities by raising them to certain powers. We generally known about fundamental quantities and the derived quantities in the previous classes. So here the physical quantities means which are the derived by the physical fundamental quantities. That derived quantities or any other quantities we are going to express in the form of fundamental quantities. Then what is the rise of the rising them to certain powers means, is there any second square? That square tells the power should be for the fundamental quantities. Okay, dimensions are always expressed in the big bracket. We should write the dimensions in the bracket inside the bracket. Okay, then it is used to describe the nature of space, means 3D space. In 3D space means there are length, width and height. It is also used to mean the quality or types of physical quantities. It is used in the form of to express physical quantities. So here are the dimensions, means these are the physical fundamental physical quantities. So by using these quantities we are expressing other quantities in the form of fundamental physical quantities. Example, length means here we are generally used for the area. Area means what? Length into breadth. Length and breadth also measured in the form of length, means length and breadth expressed or it gives the which quantity, it belongs to which quantity. So length and breadth is belongs to the length. So that's why we are going to convert the area to the dimensions, means we have to use L. Okay, for and next mass. For the mass we have to use M. So here you have to observe these things. The all the letters or the main letters or capital letters of the quantities, and it should be written in inside the bracket. Okay, next time is T, temperature means theta. Some other list of the dimensions they expressed in the form of K. Okay, temperature is expressed in the form of theta. In other books, textbooks, they used K instead of theta. They used as K for the temperature. Let us see some other derived physical quantities in the form of dimensions, means the converting the SI unit system to dimensions. So area is equals to, the formula for area is length into breadth. So length and breadth both are expressed or indicates the length, means length is measured in the form of meter and breadth also in the meter. The SI system is meter square. So in the form of dimensions, this is length is indicates the L length and breadth also indicates the length, means the breadth is measured as a length, so that's why we used L. Then formula L into L is L square, so that is the power. Okay, that should be raised them to the certain power, means L into L is a L square. Okay, generally. And second one, for the volume is equals to length into breadth into height. We are using length is measured in the L, breadth is measured in the L, and height is also measured as a length. And L into L into L, L is a L cube. So we have to write in the bracket. Next one, velocity. Velocity is equals to displacement per time. So this is very important. Generally they asked velocity and acceleration. Okay, in the CET examination, they generally they used to ask about the what is the dimension for the acceleration. Okay, so this is a displacement means that is a length, that is L. Time, generally we used time in the seconds in a SI system, but this is a dimensions, but that's why we used T. Therefore this T will come, it is in the denominator, then it comes to the numerator. That's why L T to the power of minus 1. This should be written in the bracket. Okay, the SI system is meter per second. Acceleration is equals to change in velocity per time. Means here already we used velocity in the previous, so L T to the power of minus 1 divided by time. Then it should denominator T is goes to the numerator. That's why acceleration dimensions for acceleration is L T to the power of minus 2. Similarly for the force, force is equals to mass into acceleration. Mass we used M. Dimensions for mass is M into acceleration previously L T to the power of minus 2. This is a multiplication, that's why force is equals to ml t to the power of minus 2. We have to write all the dimensions in the bracket, in a one single bracket. Okay, then SI unit system for force is Newton. These are derived by the expressions are in the form of small simple formulas. Means the definitions for modulus of elasticity is tangential stress divided by shear strain, that is force by area. So this is a general formula to identify the define the modulus of elasticity. Okay, force is ml t to the power of minus 2, area is L square. So here we can divide, means numerator L is cancelled and denominator length is 1 is cancelled. So finally the remaining one L is comes to the numerator. Then m L to the power of minus 1 and t to the power of minus 2 is the dimensions for the modulus of elasticity. So all the here I am going to discuss about 25 formulas and with the dimensions. So why I am going to discuss about this means this is very important. You don't know about how it comes, so that's why I am explaining in the form. Okay, you have to know. If you understand easily means you can remember or you can calculate in exam. Okay, next one is surface tension. Surface tension formula is force by length. Means the surface tension means in a, like for example water drop. Water drop is existed as, so here this is the surface tension for a water drop. Means force existed in the length. So generally water drops, all of you know about the water drops. So this is the area of a water. This force is on the area. Okay, that's why this is a surface tension. Where is the surface means this is a surface of water. So here is some tension means what? Means force exerted by the water drop to the area. Okay, surface tension, force divided by length. Force dimension is ml t to the power of minus 2 divided by length L. Finally the surface tension dimension is L is 0 means here is going to cancel, and t to the power of minus 2. You can also written in the form of m t to the power of minus 2. Here the mistake is you have to write in a bracket. Okay, next one is the velocity gradient. Velocity gradient is change in velocity divided by change in displacement. So this is expressed in the form of change, means this delta means change in velocity and change in distance. Okay, so velocity means L t to the power of minus 1, distance means L. So L get cancelled, and velocity gradient formula or dimension is t to the power of minus 1. Okay, this is a SI unit for per second. Next one, coefficient of viscosity, force divided by area into velocity gradient. Already previously we find out velocity gradient. So these are the why I am going to show these things means these are the simple mathematics converting the quantities into the another one quantities, means derived physical quantities to the fundamental quantities, and we are denoted in the form of dimensions. Okay, then coefficient of viscosity is equals to force divided by A into dV by dt. dV by dt means change in velocity by change in distance. Okay, so d by dx is also shows change. Then for the force m L t to the power of minus 2 and divided by L square means area formula, then dV by dx means velocity gradient, that is t to the power of minus 1. Then finally this L and L get cancelled. Finally here is a one L and m L to the power of minus 1 and t to the power of minus 1. So this comes to the numerator means it will be plus. Okay, then t to the power of minus 2 plus 1, that gives t to the power of minus 1. SI unit is kg meter, so kg per meter per second. Okay, next one, gravitational constant. We generally know about the what is the gravitational definition of gravitational force, that tells in the form of mathematically F is equals to G m1 m2 divided by r square. So in this case this m1 and m2 are gravitational force, means this F is means force. This is a gravitational constant. m1 and m2 are the masses, then r is the distance between the m1 and m2. Okay, for this formula we are derived for the gravitational constant. G is equals to F r square divided by m square. So this is by the formula. Okay, then for the force m L t to the power of minus 2 and L square divided by m square. M is the mass, L is the length, this is the radius, and this is the dimensions for force. Then m power minus 1 L cube and t to the power of minus 2 is the dimensional of gravitational constant. Okay, so here is a simple mathematics, that is m and m will get cancelled. Here one m is in the denominator, and L into L square is L cube and to the power of minus 2 is here. Okay, so in the next class we are going to further contents. Okay, thank you.